After a brief absence from posting, I'm back and I'm going to be posting a series of practice problems for the next little while, one problem for each day, starting with practice problems for DC series and parallel networks. And next we'll move on to DC branch current analysis, then AC circuit analysis, power analysis, and AC transformers. This will take quite a while to get through all of the practice problems that I have in store, but stay tuned and I'll be putting one up every day. If you want to have them all at once, I will be posting them as I develop them on my stand store at this web address. This is practice problem number 1. In this problem, we are to determine the voltages V1 and V2 in this network. To start with, we can redraw the original network like this. This series combination gives us 6 k ohm and 3 k ohms in parallel with 6 k ohm, and it is given by 3 k ohms times 6 k ohms all over the quantity 3 k ohms plus 6 k ohms, which gives us 18 k ohms over 9 k ohms, or 2 k ohms. We can redraw the circuit now to look like this: 2 k ohm resistors in series. Before continuing, I'm going to use something called the voltage divider rule. So let's take a quick look at that. The voltage divider rule is demonstrated by the solution to this circuit: the voltage source feeding 2 series resistors. In this circuit, the source voltage will be split into 2 resistors, and Kirchhoff's voltage law tells us that the voltage drop across 2 resistors must sum to equal the source voltage. Therefore, the voltage drop across each of these series resistors will be equal to that resistor's value divided by the sum of the resistors in series times the source voltage. That is, V1 is equal to R1 divided by the sum R1 plus R2 times the source voltage. And V2 is equal to R2 divided by the sum of R2 plus R1 times the source voltage. Now, the voltage divider rule can be sequentially applied. V1 is equal to 2 k ohms divided by the quantity 2 k ohms plus 2 k ohms times the 12 volts, which equals 6 volts. Looking at the original network, we can again use voltage division. The voltage drop across the 2 k ohm resistor is 2 volts. This gives us the solution to the original problem, as in most cases there is more than one way to find a solution. Another way would be to use Ohm's law to find the current flowing through the areas of V1 and V2.